We're going to identify and use vertical, adjacent, complementary, and supplementary angle pairs and perpendicular lines. Then we're going to construct perpendicular lines, which, by the way, you already know how to do. When we constructed the bisector of a segment, that's the exact same construction we're going to use to construct perpendicular lines. That bisector was perpendicular to the segment that it bisected. Okay? So, some terms we need to know. All right? Adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior point. Now, that's a very wordy definition for a fairly simple concept. Outside of math, the word adjacent basically means next to. Okay? You might even say next to and touching. Your neighbor's lawn is adjacent to your lawn. Our room is adjacent to Mr. Scott's room. Okay? Now, in the same plane, we're not going to have to worry about that. We're going to be dealing in a plane. Have a common vertex. So look here at this example. There's the common vertex for angle 1 and angle 2. A common side, that ray right there is the common side, but no common interior point. Any point that's in the interior of angle 1 is not in the interior of angle 2, and vice versa. Okay? Now, all of those conditions are necessary to mean next to and touching. If I see why. Look at the non-example. Okay? Look at angle 3 and angle ABC. Angle 3 and angle ABC. They have the same vertex. They have a common side. Ray BC is a common side. But here's the problem. Points that are interior points for angle 3 are also interior points for angle ABC, aren't they? So instead of one angle being next to the other one angle's inside the other. Well, we don't want to call that adjacent, do we? I mean, because if we use that as adjacent, then all of us would be adjacent to this room because we're inside of it. That's not what we want the word adjacent to mean. So that's why that's on there. Okay? Then look at the other non-example. Here we have angle ABC and angle 3, and they're really close to each other, all right, but they're not quite right next to each other, are they? Okay? So adjacent angles look like this or this, not that. The first one and the third one. All right, on this one, any point that's interior for angle 1 is not interior for angle 2. But on the third one, that point right there is interior for angle 3. It's also interior for angle ABC. Those are the two angles we're talking about. Angle 3 and angle ABC. Now, is angle 3 adjacent to angle 4? Yeah. But angle 3 is not adjacent to angle ABC. Right, now if we made Z, X, Y, angle 1 is not adjacent to angle ZXY. It's inside of angle ZXY. See the difference? All right, a linear pair is a pair of adjacent angles with non-common sides that are opposite rays. A linear pair, look at the name, linear. They make a line. Pair, there's two of them. Linear pairs are adjacent angles that make a line. Linear pairs are adjacent angles whose sides are opposite rays. Linear pairs are adjacent angles that form a straight angle. Okay? Now, since we know that the measure of a straight angle is 180, if you add the measures of the two angles that form the linear pair, what will you always get? 180. Okay? One of the most useful types of angles we're going to run into are vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. Now, let me just point something out here that may or may not be obvious to you. You've probably never thought about it before. When I intersect two lines, how many angles are formed if I don't overlap any of them? 4, right? As long as you don't overlap any of them, you get 1, 2, 3, 4. Always. The ones that are not adjacent to each other are called vertical angles. So, what angle is not adjacent to angle 1? 3. It's the only one that's not adjacent to angle 1, isn't it? Angle 1 and angle 3 are a pair of vertical angles. What's the only angle that's not adjacent to angle 4? Angle 2. Angle 4 and angle 2 are another pair of vertical angles. All right? Vertical angles turn out to be so useful because vertical angles are congruent. And they have the same measure. So that's going to be really handy. You can see how that's going to be handy, can't you? Okay? All right, so look back at these. Do you think you got them all? Adjacent, linear pair, vertical angles? Yep. Did linear pairs have measures that add up to 180? Linear pairs are always supplementary to each other. All right, let's see if we can do it. So this is from page 51. Nope, 50. Name an angle pair that satisfies each condition. So what we're doing now is we're doing examples of learning target 11. Okay? You know, I've never actually mentioned that, but I always do that on the examples. If y'all notice, I always have the learning target that matches the examples if the examples match the learning target. Because sometimes we learn stuff that's not a learning target, right? But whenever the examples match the learning target, I put the learning target up there. So, name an angle pair that satisfies each condition. We need two acute vertical angles. Now, vertical angles are formed when you have intersecting lines. So, see ray VX? It's in the way. It mentally erase that. And now do you see where we get our vertical angles? This one and this one are a pair of vertical angles. This one and this one are the other pair of vertical angles. You with me? You got to get the ability to do that. Now, obviously, do not mark them out on your book. If you draw that on your paper, is it fair game to then erase that one ray? Sure. Draw it back in later if you need it for the next problem. Erase it to make this one easier. Yeah, it makes sense to me. Now, they want the acute vertical angle. So which are the acute ones? Yeah, so angle Y, let's see, what was that letter I covered up? V, Z, and angle U, V, W. Yes. That's awesome. Somebody just tear it out? All right, number 2. Two obtuse adjacent angles. All right, now this one's a little more complicated. We need a pair of obtuse angles that are adjacent to each other. So they must be adjacent to each other, and they must both be obtuse. What do you think, Dan? W, V, Y, that's definitely obtuse. Yeah. If I'm going X, V, you see that they're not adjacent. They kind of cross over. What do you think, Clay? W, V, Y, and Y, V, U is not obtuse. It's straight. So, C, D, D, U. That'll work. We found a pair that works. That's our answer. There may be other answers, but that one that works. So angle X, B, C, angle B, D, U. Good. Wow, that was a little tougher than you'd think. When I tell you just to name something, you think it ought to be easy. Got to find the right one. All right? More terms. You know these terms. First, vertical angles are congruent. Okay, I'd already mentioned that, but there it is. That later on will be a theorem, which is basically a law of mathematics that is proven to be true. Okay? Vertical angles are congruent. So whenever you have a pair of vertical angles, they are congruent. Now, that doesn't mean that every pair of congruent angles are vertical angles, does it? It just means that if the angles are vertical angles, then they are congruent to each other. You know what complementary angles are. They're two angles with measures that have a sum of 90. Now, it's two angles. If you have three angles that add up to 90, well, good for you, but we don't call them complementary. It's got to be two angles that add up to 90. Same thing with supplementary. It's got to be two angles with measures that have a sum of 180. Okay? So if you have three angles, 60, 60, and 60, they do add up to 180, but we do not call them supplementary. So, complementary angles, two angles with measures with a sum of 90. Supplementary angles, two angles with measures that have a sum of 180. If you get confused on which one's which, I just go in order. Alphabetically, C for complementary comes before S for supplementary, and numerically, 90 comes before 180. So the C goes with 90, the S goes with 180. Okay? And, like we'd already said, the angles in a linear pair are supplementary. Now, geometry is a very logical type of math to study. All right? All math is logical. But geometry is, in many cases, just pure logic. So we may start with something like this. We may be given a linear pair, and we'll think to ourselves, oh, linear pairs are supplementary. Then we'll think to ourselves, supplementary means two angles that add up to 180. So our conclusion will be, if I add the measures together of these two linear pairs, I'll get 180. Okay? See how it's just one true fact leads to another fact, leads to another fact, gives us a conclusion. That happens a lot. All right, back to page 50. Number 5. Nope, that's a 3. Number 3. Cameras have lenses and light to capture images. Believe it or not, cameras used to have film in them. They did. They had film. I think digital cameras are just magic. Film, I understand. Digital cameras, just magic. All right, so cameras use lenses and light to capture images. A, what type of angles are formed by the object and its image? In other words, what kind of angles are angles 1 and 2? They are vertical angles. Now, they are also acute angles, but what they're wanting you to say is vertical angles. Okay? Now, B, if the measure of angle 2 equals 15, what's the measure of angle 1? Because vertical angles are congruent. What would happen if you had a cat, and this would be neat too, but if you had a cat and then you taped like a piece of bread to its back and buttered it, and you drop the cat, what's going to happen? Because there's two things. Cats always land on their feet, and the buttered side of the bread always hits the ground. Ooh, it would hover. We could make flying cats. They'd be like Iron Man. There'd just be cats everywhere hovering through the room. I just thought of it. All right. Perpendicular lines. Okay, I know I started this, but let's get back to geometry. Lines, segments, or rays. So, lines or parts of lines that form right angles are perpendicular. Lines or parts of lines that form right angles are perpendicular. We generally say perpendicular lines, even if we're dealing with segments instead. And I'm okay with that. Now, there are some facts about perpendicular lines that you already know, but we need to mention them again. We need to have these fresh in your mind. All right, so perpendicular lines intersect to form four right angles, because when two lines intersect, we've already gone over, you get the four angles as long as they don't overlap. Perpendicular lines, all four of those angles are right angles. Perpendicular lines intersect to form congruent adjacent angles. Well, of course they are. They're all 90 degrees, aren't they? So they're all congruent to each other, and then you can pick out pairs of adjacent angles. So their adjacent angles are also congruent angles. Segments and rays can be perpendicular to lines or other line segments and rays. So again, lines or parts of lines that form right angles are called perpendicular. And the right angle symbol in the figure, that one, indicates that the lines are perpendicular. So we use that little symbol to mean right angle, 90 degrees, and perpendicular. Well, how do you know which one it means? It means them all. So use whichever one's most convenient for the problem you're working on. Okay? Now, the upside down T is the perpendicular symbol. So this means line AD is perpendicular to line CB. Okay? All right, did you already know all of those things about perpendicular lines? Yeah. Number 4. The measures of two complementary angles are 7x plus 17 and 3x minus 20. Find the measures of the angles. If they are complementary angles, what will we get when we add their measures together? 90. That's one of our basic ways of coming up with equations, isn't it? Add things together because you know what the result is. So add 7x plus 17 plus 3x minus 20 because the result must be 90, because that's what complementary angles are. All right, work that out, see what x equals. Once you get x, see if you got what I got. Did you? All right. Now we're supposed to find the measures of the angles. So one of them is 7x plus 17. So that becomes 7 times 9.3 plus 17. All right, so somebody use your calculator for me. What's 7 times 9.3? 65.1 plus 17. All right. Now, to get the other one, we've got two ways. One way is, I know that these two measures have to add up to 90, so couldn't I find the other one simply by doing 90 minus 82.1? Yeah. The only danger in that, the only danger, is if 82.1 is wrong, I'll miss the other angle as well, won't I? Okay? So, and if you want to go for it, that's fine. I got no problem with that. But if I do 3x minus 20, that becomes 3 times 9.3 minus 20. What's 3 times 9.3? 27.9 minus 20, so I get, now, since I found those two independently, if I add together and get 90, I can be pretty confident that I've got them both right, can't I? I mean, let's put it this way. The odds of missing what x equals and then getting one of the numbers angles right and then missing the other, that's all getting slim, right? So if it works out that those two add together to 90, I'm feeling good about it. Do they? Yeah. So I think we got number 4 correct. Let's do number 5. Lines x and y intersect to form adjacent angles 2 and 3. If the measure of angle 2 equals 3a minus 27, and the measure of angle 3 equals 2b plus 14, find the values of a and b so that x is perpendicular to y. Oh, I'm glad I read the whole thing. X is perpendicular to y, or at least it's supposed to be. All right, so we form adjacent angles 2 and 3. So just randomly pick one of them to be angle 2, but now I can't randomly decide which one is angle 3. Angle 3 has to be adjacent to angle 2. So there's 2 places it can go. I'm going to put it there. Okay? The measure of angle 2 equals 3a minus 27. The measure of angle 3 equals 2b plus 14. Find the values of a and b so that x is perpendicular to y. X perpendicular to y. I could use that little symbol, couldn't I? So, they both have to equal 90, don't they? Since the lines have to be perpendicular, the angles have to be right angles. If the angles are right angles, their measures are 90. If the measure of each angle is 90, 3a minus 27 equals 90, and 2b plus 14 equals 90. All that seem logical to you? All right, solve both those, see what you get. Question? Everybody got what I got? All right, good. Now, in a diagram, don't over-assume things. All right? What it boils down to is this. I'll let you read that on your own. If it looks like a line, it's a line. If angles look like vertical angles, they are. If they look like a linear pair, they are. If they look adjacent, they are. Other than that, that's about it. If it looks collinear, they're collinear. Don't assume that if something looks perpendicular that it is. Do not assume that. It has to be marked or given to you. Don't assume that if two angles look to be about the same measure, that means they're congruent. Do not assume that. You have to be told that they are. Or figure it out, prove it yourself. Same thing with segments. Okay? So, do not assume measures. Don't assume measures. If you never assume measures, then you should be okay. All right? So on this one, can we assume that angle CAD, which would be here, and angle DAB, this one, are complementary? No. In fact, they're not, are they? Because the right angle they have marked involves a little more space, so no. What about and explain, your explanation is never assume measures. Okay? What about angle EDB, and angle BDA are adjacent, but they are neither complementary nor supplementary? That we can. We can tell they're adjacent, and we're not assuming measures to assume they're not complementary or supplementary, because that's a 90-degree angle. So obviously, when I add those two together, it's less than 90 as my result, isn't it? So yes, that's your assignment.